Okay, we're on Geometry Slow Review, worksheet number 15. This is Ms. Fisher, and I'm back to help you with some trigonometry. We are doing a multi-step problem here, so I'm going to tell you to check right now and make sure you've done worksheet number 8, and make sure you know what you're doing on that. If not, you should stop this video right now, and you should go look up the video for worksheet number 8, which was some basic trigonometry, just solving for missing sides. Okay, we're still doing trigonometry, but we're going to do a multi-step problem. It'll be real helpful if you kind of know what you're doing, just solving a right triangle, solving for missing sides. Okay, we're going to look at a word problem. So, assuming that you're okay with the trigonometry, I'm going to go ahead and write one thing on the top of my page that I like to think every time I have a problem involving right triangles and trigonometry. And that's my good old friend, SOHCAHTOA. Okay, you might want to grab your formula sheet, if you have a formula sheet that your teacher gave you that you can use on the SLO. If you haven't seen it, we are going to give you a reference that you can use for remembering your trig ratios, where we wrote out sine is equal to opposite over hypotenuse. So you don't need to worry about memorizing that, but we're going to have to need that. Let's take a look at the problem. Hugo is standing on the top of St. Louis's Gateway Arch, looking down on the Mississippi River. This picture's a little dark on your paper. Follow along. Here's the river. There it is. And Hugo must be right up there. Okay, the angle of depression to the closer bank is 45 degrees. Angle of depression, we need to remember that is definitely a vocabulary word that you should remember. And I like this picture, kind of helped you out a little bit because they have this nice dotted line drawn in here across the top. From the point where Hugo is standing, angle of depression is always down from some horizontal line down to some point. So we've got an 18-degree angle of depression right here down to this first line that I've got across. And just to help us out, I'm going to highlight this triangle. And I actually like to do this problem by drawing two triangles. So I'm going to redraw that triangle right over here. And I'm going to go ahead and note that I have an 18 degrees angle of depression. I've got this, and I've got 630. Oops. 630 on the side. Sorry for the jumpy screen there. For my height. We also have a 45 degrees. And I kind of jumped ahead here in the problem maybe a little bit in my reading because I went and looked at my picture. 18 degrees was the angle of depression to the further bank, which is over here. And then we've got 45 degrees is the angle of depression to the closer bank. So I'm picking those two spots on either side of my river. And I have a 45-degree angle of depression, which again is going from the horizontal down to some point. This time I'm going down to this point. And this is going to create a second triangle. So I've got a second right triangle right here. And I've got 630 again for my height. So that helps me to see a little bit better, and it maybe helps you remember the angle of depression and just see a simpler picture. Angle of depression, horizontal down to some point. Angle of depression, horizontal down to some point. Okay, now the next thing I'm going to do is I'm going to clean this up and make it look a little more like what we want, which is a right triangle that we can solve. And most of you will remember that the angle of depression is equal to the angle of elevation is one way of saying it. The angle of depression is the same as the angle of elevation down here. Okay, if you remember, the reasoning is that we have parallel lines. So my dotted line here is parallel with my horizontal line on the bottom. So we've got a pair of alternate interior angles. Same thing over here. I've got 45 degrees, so I've got 45 degrees inside. And if you want to, you can really clean up your picture and you can get rid of this part if that makes you feel a little better and you like to see the picture looking like that. Okay, now I'm just going to focus on solving, but what am I going to solve for? Let's finish reading the question. It says the question, the arch is 630 feet tall, estimate the width of the river at that point. So we want to find the width of the river, and the width of the river is going to be over here. I know it's a little hard to see. Again, that picture is a little dark. Let's try this. Maybe we can see that part. Okay, so what my process here is I'm going to go ahead and start with this big triangle, but I'm actually finding too much. If I solve this, I'm going to solve for this whole length down here, and maybe we'll just call that x for that entire length. But that's really the point, That's going from the point at the base of the arch where he's standing in all the way over to the other side of the river. In my pictures over here, I'm looking at the big triangle, and my x is this entire length right here. Now, my thought process is, I want to find this part over here. So I want to get rid of this part. This part's too much, this part right here. So maybe I could find this length, and then I could subtract that from x. So I'm going to go ahead and call that y, just this part over here. It's really outside the river. And then at the end, I'm hoping that maybe I can get two numbers, and I can do something like x minus y, and get my final width of my river. If we take this triangle's really inside of the other triangle. It's really about there in your picture. So I'm going to keep it separate, but I'm using that idea that that triangle's inside, and I'm going to label this part right here my y, just like that part. And now I'm going to go ahead and solve for x and solve for y. So this would be what you did on your other review worksheet. Let's go ahead and do our trick. Remember, we're going to label our triangle first. So from my angle down here, the angle that I know, my 18 degrees, I've got 630 as my opposite side, and the side I'm looking for is my adjacent side. And if I'm using opposite and adjacent, I'm looking at this one right here. So we should be using our tan ratio. Tan of my angle, 18, equals my opposite over adjacent, so 630 over x. And we're going to solve that. You might notice that your variable is in your denominator. So if you're thinking divide, you are correct. Okay? If you're thinking make a proportion, put it over 1, and cross multiply, you are also correct. In your calculator, you're going to end up doing, not that, 630 divided by tan 18. Go ahead and do that. Make sure you can get the right answer. And for my answer, I'm getting big number, 1,938.9. Let's round it to the 10th place. We don't need much more than that. I think that should do it. And again, that is the entire length. Check your picture. That's the entire length all the way across, which is too much for my answer because I just want this squiggle part right there. So I'm going to go ahead and solve the blue triangle now. So I'm looking at my 45-degree angle. I'm going to label. From my 45 degrees, I've got my opposite. I've got my adjacent. Hopefully you feel good to do this one on your own now, and you can maybe just check your answer. You should be using, again, the tan ratio, because opposite and adjacent. So tan 45 this time is equal to 630 over y. Same idea, we've got our variable in the denominator. You could cross multiply here, make it a proportion. Some of you even like to just think multiply by y on both sides, but you're going to end up dividing by tan 45. Type that in your calculator, and I'm getting an answer of 630. That looks familiar. Wasn't 630 my height? Maybe you noticed, that's a 45-degree angle. Anybody remember 45, 90s? Our legs are equal. Yeah, you really could have skipped all of this work, and you could have gone right to here just by remembering that fact. But that's okay. That was good practice for us. So we're going to finish this problem off. We're almost done. We did all the hard work. Okay, there it is. That was just a little technical error. We are going to look at our picture one more time. We're going to read the question. It says, estimate the width of the river at that point. Width of the river down here, again, is this squiggle part. So I've got my whole length x, and maybe I'll just jot that down on the picture. That was my 1,938.9. And then I've got my distance to the river, which was my 630. And doesn't it make sense if I take the big distance, I subtract this little part over here, I'm going to be left with my answer, the width of the river. And I don't have to swim the river, so that's a good thing. Just put some numbers in here. So I've got my 1,938.9, that was my x, minus my 630, that was my y. Type that in your calculator. I'm getting an answer of 1,308.9 feet. You might be asked to round to the nearest foot on this one. If that's the case, we would go ahead and say 1,309 feet is the approximate width of the river. Couple variations to this problem. You might be given the angles of elevation instead of the angles of depression. One of the things I just want to remind you of, if you're not given a picture and you have to make a picture, is that your smaller angle is always going to be further from your vertical line. Your bigger angle is going to be closer to it. So don't mix those up, and you should be just fine with this problem. Find both lengths and do a subtraction at the end. Great job. Try another one on your own.